In section 7.4, we are going to go over modeling changing amplitude and midline. So this is going to be for part 1 of your homework assignment. I'll write it on there in a minute. Part 1 of your homework assignment, the main thing that we are going to introduce this time is frequency. So we have not talked about frequency in terms of our wavelengths yet. So frequency is the amount of revolutions that are made in 1 unit of time. The period is the amount of time that it takes to make 1 revolution. So let's look at an example of that. We know with period, we've talked about this plenty of times. Let's think back to our Ferris wheel. So our Ferris wheel, if we were talking about the period, we would want to know how long does it take to make 1 revolution with that Ferris wheel. Well, a common time that we worked with was 8 minutes to go completely around that Ferris wheel 1 time. The amount of revolutions made in 1 minute, so if we were talking about the frequency, if it took us 8 minutes to make 1 revolution, then how much of a revolution would we make in 1 minute? So then we would have 1/8 of a revolution in 1 minute. So what you notice about frequency and period when we compare the two, they are always going to be reciprocals of one another. So if we know the frequency, we can easily find the period, and vice versa. If we know the period, we can easily find the frequency. So that makes it very nice, not too much new stuff to learn for part 1. And we will go on for our first example. For example number 1, we have find a possible formula for the trig function whose values are in the following table. So this is nothing new. This is a review of actually what we've done before. So a couple of different ways that you could look at this. You could graph it if you wanted to. Let's go ahead and just look at what a graph would look like of this. Looks like we're going out to 24 on our x-axis. The lowest we're going to go is -6. We'll say it's down here. -4, -2. Okay, so we're going to start off 0 at -4. And then 4, and I'm just going to kind of estimate these on here. 4 is at -6. 8 is at -4. 12 is at -2. All right, and so we're just going to kind of get the idea of what we're doing here. So this is this does not do curve very good. There we go. Thank you. Curve. All right. So what we have here is we have a sine, and actually it's going to be negative sine because sine starts at the midline and goes up normally. This starts at the midline and goes down. So I'm going to start off knowing that I have a negative sine function. Get a little space for my amplitude. My amplitude looks like it's going to be 2. So midline was -4. So 2 above and 2 below is our highest and lowest. So our amplitude is going to be 2. All right, we need to know what our period is. I'm actually going to look back here at our table because I did not write down my x values. So how long did it take to complete 1 period? For sine, this is our midline. We have to skip 1 midline and go to the next. So it looks like our period is going to be 16. Okay, so period is 16. So that means that our b value is equal to 2 pi over 16 or pi over 8. So we have pi over 8. And we'll just use t as our variable. And it looks like we moved down 4. So midline was at -4. And that is our equation. So that's how we would do it if we're looking at that graph. But I do want you guys to be able to do this without looking at your graph. So let's start this all over. We know what the answer is, but let's see if we get that same answer doing it a different way. So now I just want you to look at this table. The only value we're going to get from our x's is the period. That's the only part that I need my x values for. Everything else is going to come from my y value. So the first thing that I'm going to do when I'm looking at this is I am going to first identify our high and our low. So the highest this graph is going to get is -2. So let's just mark that as our high. The lowest it gets is at -6. And then -4 is our midline. So we're starting off times 0 at our midline. So that means I'm going to use a sine function. Then our very next step over, it goes to a low. So then I know it's a negative sign because sine usually starts at the midline and goes up. So I know I'm going to go down. So I have a negative sine function. We also next need to find out what our period is. So our period we're going to get up from up here at our x values. And then like I said, since we're doing sine, we're going to start at the midline. We're going to skip 1 because that's the middle of our sine wave and go to the third midline. So from 0 to 16, that gives my period at 16. Then we can easily find our b value. It's 2 pi over 16 and pi over 8. And then I'm just going to use t again. And then our midline, so we know what our midline is. We already identified that. So we know we're going to have to move down 4 because that's what our midline ended up being. And then to find our amplitude, all we have to do is find the difference between our midline and our low, or our midline and our high, and just make sure that they're both the same values. And both of those values are going to be a difference of 2. So that's the way that I'd really like you guys to be able to do that, is to look at that data and be able to write the equation without having to graph it if you can. Now this is where we get into something a little bit new. So example number 2, we have the displacement of a mass suspended by a spring is modeled by the function h of t equals 7 sine of 8 pi t. Now, this is not quite yet on this part 1 yet, but we are going to start getting back into some real world models and some real world applications of these sine wave functions. So where h of t is measured in centimeters and t is measured in seconds. So now we know that our height is in centimeters, time is in seconds. We need to find the amplitude. Well, that's nothing new to us. We know right where to find our amplitude. Our amplitude is 7, and it's 7 centimeters. Our period, well, we know what b is. So because we know what b is, we can easily find our period. So p is going to be equal to 2 pi over b, which was 8 pi. So therefore our period is going to be 1/4. And then what we learned about frequency today is that frequency is the reciprocal of period. So if period is 1/4, then frequency is 4. And then we will look at example number 3, and then that's the last one for today. Example number 3 well, it is exactly the same as example number 2, just different numbers. Here we have the displacement of a mass suspended by a spring is modeled by the function 13 sine of 14 pi t. We want to find the amplitude. We know the amplitude is going to be 13. We know that the period is going to be, well, b is 14 pi, and p is then going to be 2 pi over 14 pi, which is then 1/7. So our period is 1/7, and therefore our frequency is 7. And that's all you guys have for your homework for 7.4 part 1.